Hello, in this video we'll present the EXPLORE Machine Learning Data Challenge, which is centered on finding optimal lunar traverses. My name is Nick and I'm here together with my colleague Giacomo to tell you all about it. We are very pleased to present to you today the EXPLORE Lunar Data Challenge at the first International Conference on Lunar Search and Rescue. These data challenges are brought to you by the lunar and communication teams of the EXPLORE project, and we kindly acknowledge the funding received from the European Union's Horizon 2020 Research and Innovation Programme. First of all, the EXPLORE Lunar Data Challenge is not just a single data challenge, but consists in fact of three different challenges. On the one hand, we have the public and classroom challenge, which involves interactive and engaging activities about machine learning and lunar exploration. The materials for the classroom challenge are suitable for in-class activities and are geared at roughly 10 to 14-year-old kids. The Machine Learning Lunar Data Challenge, on the other hand, is aimed at using machine learning techniques to identify specific features on the Architis dome on the Moon. It is primarily targeted at students, researchers and professionals in areas related to planetary science, machine learning, deep learning or data processing in general. So this presentation covers the Machine Learning Data Challenge, but anyone interested in the Classroom and Public Challenge is of course warmly invited to visit our website exploredatachallenges.space. So the main area of interest for our data challenge is the Architis dome on the Moon. This dome is located in the Mare Frigoris. To the south of this dome, you'll see a long rail that connects several craters and boulders and mounds. Its heterogeneity makes this area very well adapted to this challenge. So in the next couple of slides, Giacomo will explain in more detail the objectives of the Lunar Data Challenge, as well as the data sets that are prepared and the different steps of the Machine Learning Lunar Data Challenge. Giacomo, over to you.
Thank you, Nick. As anticipated, the objectives of this challenge are related to the landform object detection and rover path design. Regarding the object detection or segmentation, we choose craters and boulders since both surface features are well known in literature, easily recognizable by human eye, and are one of the primary potential hazards for manned and unmanned rover exploration missions. Especially boulders with their centimetric to metric scale are undoubtedly a challenge for a rover with autonomous driving system. The objective of path design is to find an optimal traverse between 2 points while reaching as many points of interest as possible that we defined on the basis of the possible and various scientific outcomes that can be retrieved. For instance, sample analysis, panoramic images, and so on. Path optimization problems are useful not only on scientific mission planning but for autonomous rovers, but also in critical operations like search and rescue, where time and safety have top priority in mission planning, especially in hazardous environments such as the outer space. We prepared two datasets, one for craters and one for boulders, starting from publicly available validated datasets, from which we created labels compatible with machine learning frameworks. Both datasets consist of grayscale images at 0.5 meters per pixel spatial resolution acquired by the narrow-angle camera instrument on board of the Lunar Reconnaissance Orbiter probe with incidence angles between 16 and 80 degrees. The machine learning data challenge is composed by three major steps. The first one is the object detection and or segmentation training, in which all the participants will have to train their chosen network using the provided dataset. And then the expected result includes the trained model and all the training parameters and scores. The second step is the mapping of the Architas dome region using the model trained in step 1, and the expected results includes the Architas dome image with all the detections and a table listing all the detected features. The third step is the optimal transverse design using the outputs from step 2 and a set of provided point of interest. The expected results includes the Architas dome image with the transverse plotted and an explanation of the method used and the choice made. Finally, the jury will evaluate the results obtained by the participant on all three steps by using a mixed approach of objective and subjective methods. Now I will hand over to Nick.
Thanks, Giacomo. Indeed. So the evaluation has three steps. For the first step, we evaluate the quality of the trained model quantitatively. So we look at confusion matrix, precision, recall, map, etc. Higher scores are better for each class. In the second step is a jury-based evaluation where we evaluate the detected features and will check the number and accuracy of the detections compared to a human-made map. In step 3, we also have jury-based scoring this time of the efficiency of the designed traverse, and we will check that the traverse avoids problematic craters, boulders, mounds detected in the prior step and reach the selected regions of interest. So the EXPLORE Machine Learning Data Challenge has already opened and the first teams have signed up. So the challenge remains open until November 21st, so still some 6 weeks to go. So plenty of time to get active by yourself or be a part of a team to tackle these challenges. We'll note that the winners will be announced around December 11th, which coincides with the 50th year anniversary of the last human on the moon. And not least, winning the challenge is not only about prestige and glory, there are also prizes for the top contenders, with a value of up to €1,500, as well as the chance to win a real piece of lunar meteorite. And with that, we invite you to check out the EXPLORE Lunar Data Challenge website and sign up for the Machine Learning Data Challenge or the Classroom and Public Challenges. So we all wish you great fun in these challenges, and please do not hesitate to contact us for any questions that you have. Thanks. Have a good conference.